Hello everyone, welcome back to another short video recording. So in this video recording, we are going to see how we can carry out the bolt connection design in MIDAS Design Plus software. We need to select the bolt connection or the moment bolt connection. So once after selecting one amongst these two as per our requirement, we need to select the material for beam or column, and same goes for the plate. Here we have various predefined sections. However, if we want to define something as user defined, we can disable this option and enter the dimensions over here. We have various connections: girded splice connection, column splice, and shear connection. I'm selecting shear connection, in which I am selecting single shear. We have option for the double shear as well. And regarding the force, we can directly consider the percentage of the strength design, or else we can enter manually as well. And we can consider the eccentricity over here, like the force eccentricity. And moving on to the bolt, we are having two options where we can select the slip critical and bearing bolt, and again the material for the bolt and the type of the bolt. And how are you considering the hole type? Is it a standard, oversized, short slotted, long slotted, etc.? And we have an option over here to consider bolt hole deformation as well. And with this options, I can control, as you can see over here, my plate dimensions both in X, and if I am entering this, it will be in the Y direction, and this goes for the extension, the edge distance, and the same in the Y direction as well over here, as you can see. And there is a gap option, gap if I'm giving between the column or the other beam element, between the two elements would be considered over here. So I'm keeping this as auto for now. And for the slip factor, we have a number of bolts per side, how many bolts we need to consider, and what is the thickness of the gusset plate. And slip factor, we can enter it in the decimal format, and from here we can see various perspectives of our connection. So once all this data is entered, we can run a quick check where you can see any result which is not being satisfactory, and we need to carry out the iterations accordingly. So if you want to see the detailed report, we can select from here and we can include the input data. We can go with the design, and in the design it is getting passed. That means the software will consider the values such that, as you can see over here, the number of bolts has increased in order to meet this force criteria. And if you want to generate the drawings, we can go to the drawings and click create over here, and accordingly our drawings would be generated for the bolt connection, and we can save this drawing in various file formats. I hope this video was informative, and we will meet in upcoming videos. Till then, take care.